Hi, Professor, this is Karan, and I'll bring the second sum of the homework. In this, it's given that n is a poison, n is a poison, n be a poison process with the parameter lambda, and with parameter lambda, right? So a stochastic process has been defined saying that xt is equal to 1 if n is odd, and xt is equal to minus 1 and if n is even. So it's just a telegraph. It's just like a telegraph signal. That is, if we get as in from the in this time intervals, we have got the number of arrivals has been in odd, and in this array in this interval it has been even. Again, in this interval it has been odd. So it forms a telegraph signal here. So these are the samples of the xt. Now we have to define. Now we have to show one sec. Now we have to show the probability of xt being 1. Now probability of xt being 1 is same as probability of n is odd in 0 by t. Now as n is an Poisson process, we can substitute, we can write it as the summation of all the terms, of all the odd terms with Poisson process, that is e minus lambda t. E in lambda t raised to n upon n factorial. Now taking just the odd terms of n, we get something like this. Now when we simplify this, we get something simplify when we simplify this, we get this term, and this term can be written as sine hyperbolic function of lambda t. That's what it is. So finally we get px1 as e raised to minus lambda t into sine hyperbolic lambda t. Now similarly, when we do for x minus 1, and when we do for x minus 1, we get e raised to minus lambda t cos hyperbolic t. Now for expected value of ext, now for expected value of ext, it would be 1 into probability that n is odd, and plus minus 1 into probability of n is even. Now we have found the probability of n being odd and n being even, which is these terms. And when we simplify this, we get e raised to minus lambda t sine hyperbolic minus cos hyperbolic. Now cos hyperbolic minus sine hyperbolic is an e raised to minus is equal to e raised to minus lambda t. So we can so when we take minus outside, we get this term, and we get expected value as minus e raised to minus 2 lambda t. Now autocorrelation function is the expected value of at xt1 into xt2. So again we'll have to take 1 into probability of xt1 to xt2 being is equal to 1, and minus 1 into into probability of xt1 into xt2 is equal to minus 1. So again on expanding these terms, we expanding simplifying this term, we eventually get e raised to minus 2 lambda t1 minus t2. Now for the last question, whether now since expected value of e x is not a constant, it varies as per time t, so it's not a WSS, and if it's not a WSS, it cannot be SSS also. So the xt is neither WSS nor the SSS. But now if we take the number of arrival, now let's draw a telegraph signal here. Now just don't telegraph signal here. Now the arrival in some time interval, this to here will be independent of arrival being from here to here. If not overlapping, this has to be independent. Now since the since the output at at one interval is independent of other non-overlapping interval, it is an independent increment, and since it is an independent increment, it has to be an uncorrelated increment. Now we have uncorrelated increment, but which is not is equal to 0, and since this is equal to this and this is not equal to 0, it's not an orthogonal increment. Thank you.